Dear students, in this session we are going to discuss the basic definitions of ordinary differential equations and some applications, just brief applications of partial differential equations. Before that, so we go for the syllabus. So this is the syllabus prescribed by Pondicherry University. The name of the paper is Ordinary Differential Equations, and the total credits is 4 plus 1, 5 credits. And this is a syllabus. So this is discipline specific elective, and the unit 1 you can see we are going to discuss exact differential equations, next equations of first order but higher degree, then equations solvable for dy by dx, then equations solvable for y, then equations solvable for x, and then chlorx. All the differential equation, this kind of various types of differential equations we are going to study and find and learn the method how to find the solution of the differential equations. And the main reference book is Calculus 3, Volume 3 by S. Narayanan and T.K. Manikavasagan for units, first 3 units. And then for the 4th and 5th units, we are going to follow Engineering Mathematics 2. That is the 4th and 5th unit. This first 3 units is full of various method of solving a differential equations, and various differential equations we are going to discuss. And in the 4th and 5th unit, we are going to see the chapter name is called Laplace transforms. That is, we are going to study the Laplace transforms. Then the main application of Laplace transform we are going to study in unit number 5. Thus, we are going to solve the differential equation using a new technique we are going to study the transform. Using the transform technique, we are going to study how to find the solution of a linear ordinary differential equation of second order with constant coefficients. Okay. So this 4th and 5th unit is full of Laplace transform and its applications. First 3 units is full of learning different differential equations and the method to solve it. This is how the units are divided, and students can refer to these reference books other than the prescribed books. So you can see, you can download from internet, or you can check in the central library for these books. And these are the key contents. Students can visit these websites and check for various kind of problems and methods. Now we'll go to the basic definitions. In mathematics, ordinary differential equation is an equation containing one or more functions of one independent variable and its derivatives of those functions. The term ordinary is used in contrast with the term partial differential equation, which may be with respect to more than one independent variable. I will show the definitions. You can refer this video also. You can learn the definition from anywhere. That's not a problem. In the examination, you have to write the definition correctly, but you can write from any source. See here, what is an ordinary differential equation? In mathematics, what they say is an ordinary differential equation is a differential equation. Differential equation means the terms contains the differential coefficients. So differential equation, you can see what is meaning of differential equation. In mathematics, a differential equation is an equation that relates one or more functions and its derivatives. That is called as a differential equation. So, ordinary differential equation is a differential equation containing one or more of the functions of one independent variable and the derivatives of those functions. So, the term ordinary is used in contrast with the term partial differential equations, which may be with respect to one or more independent variables. Okay, this partial differential equation we are going to study next semester, but here we are going to concentrate only on ordinary differential equation. There will be only one independent variable. If there are more independent variables, then we come to partial differential equations. Okay, this is an example. See the geometrical view. You can see this is Navier-Stokes differential equations. You can see, but this is the solution of a Navier-Stokes differential equations. You can visualize it, but that is partial differential equation. Okay, so what is in general? This is the ordinary differential equation. It's an equation containing one or more functions of one independent variable and its derivatives. Suppose y is depending on x, then we can say that y equals to some function of x, y equals to f of x. And what is the derivative of y with respect to x? Y dash, that is dy by dx. So an ordinary differential equation is an equation containing one or more functions of the independent variable. As an independent variable I said x, and its derivatives of those functions. So now that is called as ordinary differential equation in general. Now what is a linear differential equation? A linear differential equation is a differential equation that is defined by a linear polynomial in the unknown function and its derivative. That is, that the equation will be of this form. See, this one we call it as a linear differential equations, where this a naught of x, a1, a2 or so on till a n of x and b of x, these coefficients we say, the coefficients are all arbitrary differentiable functions. Okay, they are differentiable functions that do not need to be linear. You know the definition of linear, and see these y dash and yn are the successive derivatives of the unknown functions y of the independent variable x. So this is the general form of a linear differential equation. Okay. So there are many applications of there, but you can see here we will just discuss some brief among the ordinary differential equations. Linear equations play the prominent role for several reasons. The most elementary and special functions are encountered in physics and applied mathematics are just the solutions of a linear differential equations. You can see this function, what is a holonomic function, and in most of the cases, the problems encountered in physics and mathematics, applied mathematics, most of the special functions, whichever you come across in applied mathematics, especially in also in physics, they are nothing but the solutions of linear differential equations. But when this physical phenomena are modeled with non-linear equations, they are generally approximated by linear differential equation for easier solution. In some cases, the non-linear equations, the non-linear partial differential equations are approximated by linear differential equations. So the few non-linear ODEs that can be solved explicitly are generally solved by transforming the equation into the equivalent ODE. Sorry, linear ODE. A non-linear ODE is generally approximated by a linear ordinary differential equations in many cases to get the solution. So this is the thing, and you can see here, this is an example they are given. This is the trajectory of a projectile launched from a cannon follows a curve determined by an ordinary differential equation. That is the motion the motion is described by an ordinary differential equation that is derived from Newton's second law. So many problems in nature, physics, we are end up with differential equations. Many complex problems, we are ending up with differential equations, ordinary differential equation or partial differential equations, and we need to find the solution of that differential equation, whether it is ordinary or differential or a partial differential. So we must learn the methods, various methods, how to solve a differential equation, whether it is ordinary or partial. So because many problems in nature end up with differential equations, so we must be an expert in solving the differential equation. Some cases, if you are unable to find the solution by direct methods, you can go for numerical methods. An approximate solution can be found. So that will be dealt in numerical analysis, where we get approximate solution for a differential equations. We can use softwares to derive the solutions. Okay. So there are a lot of explanations given here, but what I am telling is you just learn what is the definition of ordinary differential equation, and I given some applications. There are variety of applications. You can see they have explained all the theory, everything, and students can refer this page for more knowledge about the differential equations. Okay. There are the references given, some e-books also given, prescribed, so students can refer here and learn more. The student who is interested to pursue higher studies in mathematics and interested in research, they can refer these e-books. Some external links are given so that they get more knowledge. Okay. See, these are the softwares for solving ordinary differential equations. There is MATLAB is there, Skylab you will be studying in the lab work as per the syllabus. You will be studying Maple is there, Mathematica is there. All very powerful softwares where if suppose we are unable to solve the differential equation by the analytical methods or direct methods, whatever may be, then we get the help from these softwares, MATLAB, Mathematica, Skylab, Maple, lot more are there. You can get the help and we can get the approximate solution. That's the importance of these softwares. So many situations it helps people to solve the differential equation, whether it is ordinary differential or partial differential equations. So you can see here also what is the linear to the nth order equations. See that approximations. See the first order linear equation functions is of this type. These are not you might have studied in your lower studies, lower classes. And what is the integrating factor and what is the general solution. So already you have studied this one, dy by dx plus dy by dt. So this is the general solution. If it is a second order linear inhomogeneous or non-homogeneous functions, like this one differential equation is there. So what is the integrating factor and the corresponding solution? They have given like a tabular column. So students can refer this one. And these are the general first order linear equations and the general solutions. So, and this is an exact differential equation we are going to study. That is the first chapter in our unit 1. We will deal with these topics in detail. Okay, and what is how to convert an equation to exact form and get the solution. So like this we are going to study, and you can see how we are getting the solutions. A lot of things are given here. So students separable equations is given. So students can refer this page for getting more knowledge in the basics of ordinary differential equations.